Welcome back. We are having another session on chemical properties. Remember, this is reactions. Don't forget that we have got 5. All in all, there are 5 types of reactions. 5 types of reactions. In this case, you must know them. All of them: oxidation, esterification, substitution, elimination, and addition. So know all of them and their reaction conditions. Please. Okay, let's see. We are given the flow diagram as usual. The flow diagram below shows the steps in the preparation of an alcohol from compound Y, which is a saturated hydrocarbon. You can see that, therefore it's an alkane Y, as you know. Now fine, if we analyze quickly, you can see that now if this one is Y, then Y is undergoing halogenation. This will be substitution, that's reaction 1. And then to form compound Z, Z will be a haloalkane. Haloalkane, in this case, you don't know what type then, but haloalkane can undergo 2 reactions, remember, is substitution and elimination. For it to form an alkene, therefore this is elimination. Very important elimination in this case, because this is elimination whereby we'll need your concentrated strong base, potassium hydroxide, sodium hydroxide stuff, plus strong heat. Don't forget that one reaction condition. Therefore, yeah, this one says it's haloalkane. Fine. This is substitution. Okay. Now, an alkene can undergo, yes, only one reaction, that is addition. Therefore, this is addition. We know it's typical hydrogenation, hydration. Fine. No problem, but just say addition is okay. If they want type of addition, you can go further and say hydration. Fine. Ethanol. Now, if you add water to an alkene to get ethanol, therefore this alkene was ethene. This will give us the rest now. This is ethene. Therefore, this haloalkane here, which if you add a bromine, then this one will be now your bromo ethane. You can call it 1-bromoethane is fine. Those who like numbers, but if you call it bromoethane is fine. There's no way that you can write differently. And then you will be now in also having a byproduct here, which is your HBr, inorganic compound. Yes. And then this is ethanol. Ethanol, remember, can undergo 3 reactions mainly. One being substitution or elimination or esterification. Fine. This is compound X, and then this one, remember, 2 oxygens. Therefore, this one will be an ester. Therefore, this must be an acid. If this one is having 3 carbon atoms, already we've got 2 here. Therefore, this one must have only 1. Therefore, it will be now methanoic acid. Methanoic acid. Fine. Remember, esterification, we need concentrated this one sulfuric acid plus heat in this case. Fine. Now we can answer all the questions now with ease. Remember, analyzing this one, please just give it 5 minutes. Analyze the table, make sense of it, and it will make your answering to the question very easy. If you can adopt that approach, you will never go wrong in any question. Now let's go to 5.1. They say explain the term halogenation. When you halogenate, it's just an addition of a halogen to a compound. But if you want to show the examiner that you know more, you can even say to an organic compound. If you want to show them you know more, you can even say to hydrocarbon. This one compound, hydrocarbon compound. That's in this case, because mainly only hydrocarbons would undergo halogenation. Fine. Let's go to 4.2. 4.2, what does it say? Let's go 2 sub-questions. They say for reaction 1, which is your substitution, write down the 1 reaction condition there. Remember, if you do substitution, we need just heat. Simple. You can just write heat. If you want just gentle heat, you need maybe sunlight. Also, sunlight can provide light heat, or just UV light in this case. UV light. So all this will be correct. Now 4.2.2, yes. Write down the formula of the inorganic product. We've already written there. It will be a HBr. Very easy. When you analyze, it becomes very quick in answering questions. Now for reaction 2, that is 4.3. For reaction 2, write down the balance equation using condensed structural formula. Reaction 2, remember, that's where your haloalkane, which is bromoethane, is reacting with the strong base. Therefore, you will just write CH3 and CH2Br plus potassium hydroxide, sodium hydroxide, or even lithium hydroxide will form, in this case, alkene, CH2, CH2. Remember, elimination will have 3 products. Therefore, if I've got 2 reactants, I must have 3 products. I will have potassium bromide and then plus water. That will be the 3 products there. Fine. No problem. Let's go to 4.4. 4.4. Write down the name of reaction 3. We agree reaction 3 is just addition. Unless if you want to show the examiner that you know more than addition, you can now write hydration. It's fine. That also is acceptable there. 4.5. You are requested to write down the UPEC name of X. Compound X, we have already said we need an acid which is only providing 1 carbon. Acid with 1 carbon will be your methanoic acid. Methanoic acid. Fine. 4.6. Now they say to us, write down the name of reaction 4. Remember, ethanol can form then ester. That reaction is called esterification. Esterification or condensation. Condensation. Fine. Very easy. Now, more marks coming. For 4 marks, they say to us, using structural formulae, write down the balance equation for this reaction. That is reaction 4. Write down the balance equation for esterification. Ethanol, we know ethanol. Eth is having 2 carbon atoms. Remember, when you are drawing structures, please all the time start with carbons. Now from here, now we attach the functional group. It's ethanol OH will be here on the last carbon or first carbon. Fine. And then from there, now you can fill in your hydrogens. This will be the case. And next will be methanoic acid. It's only 1 carbon. Then now we follow by a functional group. Functional group is this. And then the remaining bond is for hydrogen. Then it will form ester. Remember, we start with the alcohol side is 2 carbons. The alcohol side and the acid side, they are joined by oxygen. That's what you should know. The alcohol side and the acid side are joined by oxygen. Therefore, the acid side must have carbonyl so that we can have our cocoa. Can you see the cocoa? Fine. No problem. Now the remaining bonds will be for hydrogens. We short hydrogen here. 1, 2, 2 hydrogens needed here. And then 1, 3 hydrogens needed. and then remember it's esterification. The byproduct will be water, hence it's called condensation. You don't have to write structural formula for water because it's an inorganic product. We write only structural formula of organic compounds. That's what you should know when you are writing esterification. Then we just only required to write structural formula of organic compounds, not inorganic compound. H2O is fine. Don't struggle writing the structural formula of water. I think this one gives us all the 17 marks in this question. Hopefully you can see how easy and straightforward it's your this one, the question of on this ester. Now on the organic compounds. So I think it's understandable. Let's if we want us to tip in this one again, we can do the other one. It's your reaction rates, not having many marks. You can do it quick. 5.1, they're telling us to say grade 12 learner use a reaction of calcium carbonate with excess HCl to investigate the relationship between concentration and rate of reaction. They're already giving you independent and the dependent variable. The balance equation for the reaction is this one. They conduct the experiment twice each with a different concentration of HCl. A decrease in the mass of the flask and the content is represented in the table below. Fine. Remember, what causes the decrease in mass is normally because this is the gas forming reaction, therefore it's the gas that is leaving the container, which is carbon dioxide. So that's the one that causes the decrease in mass. Write down the name of the apparatus used to measure in the mass. We know we use for measure the mass in this experiment, we are using mass meter. Those who are old like me, they know that we are using triple beam balance. I used to use triple beam balance. That is the old one, now is no longer used, but anyway, it's fine. Write down the name of the limiting reagent. Which one is limiting? They're already telling us HCl is in excess, therefore calcium carbonate is limiting. Calcium carbonate. 5.3, they're saying define the term rate of reaction. Remember, there are many definitions. You can't use this one. Average rate equals to delta C mVn divided by this one. So you can define using this one, but the easiest one will be just change in concentration of reactants or products per unit time. From this one, it will be just change in concentration of product per unit, change in mass of the reactants of product per unit time, change in volume, just that, or just a rate of change in concentration. Fine. So that will how easy is this definition. For experiment 1, calculate the rate of reaction in mole per dm cube in 30 seconds. Now calculate the rate of reaction in this case in 30 seconds. So we are going to now calculate the change in the carbon dioxide in this case. Fine. Can you see now we are calculating the rate of reaction in mole per second. We need moles in 30 seconds. 30 seconds. Okay, fine. Let's go. 30 seconds, remember, is from here to here. Now for reaction 1, we move from 270 to 268.4. Therefore, we are going to calculate the change in mass, obviously in that one. Change in mass give us the 270 minus 268.4, and the answer in this case give us 1.6 grams. 1.6 grams, remember, is the mass of carbon dioxide. Therefore, the number of mole of carbon dioxide will be now given mass over the molar mass, which is 1.6 divided by 44. The answer will give us, use your calculator, 0.036 mole. Fine. From this one, now they say calculate the rate, remember. Then we're going to now say, oh fine, the rate will be now change in moles, because we are saying change in moles and over change in time. This will give us a 0.036 minus 0 divided by, the time is just 30 seconds. You can write 30 minus 0, just 30 seconds is fine. Then the answer will be now 1,21 by 10 to exponent minus 3. So mole per second is part of the question. You can write it or not write it, is fine. Then 5.5, they say to us, in which experiment did the learner use a higher concentration? So it will be just in experiment 1, experiment 1. The last question saying to us, use collision theory to explain. Now collision theory is very easy when you are using, because here we're changing concentration. You just say first part will be when we increase concentration, more particles per unit volume. That's the 1 mark. Once more particles per unit volume, it means that more particles collide with correct orientation. Then the last mark will be now more effective collisions per unit time. That is how you get all the marks here. Hopefully you understand what is going on here, and then don't forget to subscribe and keep on watching, and hopefully you are getting it better. This is how we explain collision theory, especially when concentration is involved. So more particles per unit volume is about the collision with correct orientation, and then more effective collisions per unit time, because we're talking about the rate. So until we meet again in the next session, thanks a lot. Keep watching. Thank you and good luck. Bye.